You make a bunch of noise out here, so they have peace and quiet in here. Because there's no better sound than the squeak-free guarantee from Advantech Subflooring and Advantech Subfloor Adhesive.
Pete Yost here for the UnBuild It podcast. I'm here with my fellow podcasters, Jake Bruton and Steve Basic, as usual.
Hello.
Rah, rah, sis, boom, bah.
And we're going to take a recent question we got and turn into a broader discussion of foundations. So I'm going to read this to you. It's a very concise email, which is kind of nice.
Put your specs on, Peter.
I have been following you all on various platforms for many years now. One detail that I thought was really impressive is the Slab-Less Slab. But I have questions about that. Number one, since all load paths are transferred to the exterior walls, would it be possible to substitute the compressed aggregate and or insulation layer by substituting a product like hempcrete or wood fiber insulation? Number two,
Hippie.
Jake just said hippie. If not, are there any other insulation products with a lower GWP, that's global warming potential, than XPS or EPS that would work with the Slab-Less Slab assembly? I appreciate you guys sharing your expertise and advancing the industry, but please tell Steve to cut out the bad jokes.
You know that's not part of the email.
So we're going to
It's
talk
on there.
about
No, it
It's
isn't.
on there.
Slab-Less Slabs, but we're going to also talk about some recent new foundation projects that you guys have going, right?
Sure.
Okay.
Gotcha.
So who would like to jump into, can we substitute materials
I'll defer to
underneath
Jake.
with load paths?
I think before we even jump into that, we have to say there are instances in which there are load-bearing members not on the exterior.
Yeah, I've done
So-
projects with that.
Oh, there can be like point loads.
Yeah, there could be point
yeah.
loads.
Yeah.
So it is possible. You just have to understand what you're doing. So the Type 9 EPS is one of the things that we've used the most in that scenario.
The Type 9 because it has sufficient compressive strength.
Yeah,
it's
it's a
like
21 PSI or
So
something
20,
like
I thought it
that.
was 25, but it's
Yeah.
somewhere in there.
Yeah.
Which doesn't
really
sound
matter.
like much, but then that's pounds per square inch times 144. That's your square footage rating.
Yeah,
That's
it's
more than
like
porcelain tile,
1,200.
and we're not worried about porcelain tile.
1,200 pounds per square foot or something.
Yeah. So the reason that we use that is the PSI versus the R value. There are other products. We've used GPS in the same
And that's
scenario. Graphite polystyrene. I've only ever used it from Halo, but I do think that there are a couple different manufacturers now. They may all be made in the same place. I think that might actually be accurate. I'm not sure. Graphite polystyrene looks like EPS, looks like your coffee cup foam. It's a bunch of little beads, but it's black like graphite out of a pencil or graphite in nature.
Can I just interrupt to say we make sure that everybody knows what a Slab-Less Slab is?
We should.
Yeah. Sorry.
Yeah. So in the instance that Steve and I have done it, and in the next one that you and I have in the works right now, it is a perimeter footing with a stem wall on top of it to get you above grade, compacted aggregate inside that, and then 2 layers of foam, 2 layers of subfloor glued and screwed together. So there is no concrete slab in the assembly. There's a vapor barrier in that assembly, and the aggregate has to be compacted to the appropriate amount. If we had point loads, there would be concrete underneath those point loads instead of the insulation. All those little things.
And hence the Slab-Less Slab, because you don't need the slab if you can transfer all the sort of internal loads of occupants onto this. And if you have point lobes, you just put footings in.
Yep.
Yep.
So you take a hit.
And you go through the Slab-Less Slab.
Yeah. The GPS, it has it's better for the environment because its blowing agent to create the insulation is better for the environment. It is still a foam insulation. It's still not the best thing in the world for the environment, but it is better than XPS or EPS. And because its blowing agent is of a higher quality, it also off-gases less, which means it has less thermal drift over its lifetime. So while EPS claims R6 per inch or whatever it is, it's actually closer to R5 per inch 2 years down the road sort of thing. GPS loses a lesser percentage of its R value over time, and you get to claim like almost 7 per inch. I think it's 6.7 if I remember correctly. I had to look it up to know for sure.
If they're a little less.
Yeah.
EPS is like the Type 9 is like 3.8 or 3.9. GPS is like 4.4 or something like that.
Okay.
Yeah. Yeah, because even polyiso, which starts with a 7, is aged to about a 6.
It
Because
depends on
there we go.
temperature, right? Like if you put it in colder place, it ages even less, I thought.
well, it ages less. It loses
Or
the
not
gas.
ages, but the R value
Degrades less.
degrades more
Correct.
in coldest climates.
Okay.
Yeah,
So if you put
although-
it in northern Minnesota, it starts out at 7. It might be 5.8. In Boston, it starts out at 7, might go to 6.1.
And all the polyiso manufacturers have been working really hard to correct this temperature sensitivity of the R value over the range, but can't use that below grade anyway.
Yeah. So the
You
reason we
can use it below grade if, how can I say this? Not below grade. You can use it in a slab above grade,
Yes.
right? Because I've talked to the polyiso manufacturers about using it under a slab. They said pretty much you have to ensure that it isn't in water.
Yeah. Right.
Like, so if you're doing a slab on grade like we did the Johnsons, where the slab is 14 inches above surrounding grade and the grade drops off where the place is never going to flood, they don't have a problem putting it in
Yeah.
a dry environment.
yeah, I wonder how the code would interpret. You've guaranteed that.
Well, I wonder how many building
polyiso-
inspectors know the difference between
Well-
polyiso and EPS.
fair.
Don't
no
know.
offense. So the swapping of material, I would guess, is certainly possible. It's going to depend on compression rating and the ease of install and cost. I'm not very familiar with hempcrete because it's unavailable in my market, and I am not very familiar with wood fiber because it's new and no one within 1,000 miles of me is producing it. So I would have to defer maybe to somebody.
Well, I mean, the
over on my
Europeans
right.
use the wood fiber, right? I mean, they have wood fiber board insulation all over the place, exterior buildings. I mean, they have it in 2, 3, 4 inch,
It's pretty high
sections.
PSI, right?
and it is very dense material.
But we don't know if
Yes.
it would be approved for below grade use.
Yeah, that's the issue is because all of those things, if they have the ability, now it might not be in standing water, but you're going to get probably some level of moisture migration. And if it's under there for its life and doesn't have the ability to dry to the top side, say because we put a stego layer or something over the top of it, then all you're ever going to do in that material is increase saturation. Because it can never dry down because the down has always got more water.
Yeah.
So it's going to accumulate.
This gets into an interesting discussion about if we adequately protect a material from moisture, could we say that it could be used below grade? Because it's a bit of an arbitrary distinction if you can protect it from moisture in a superior way. But I bet you when you talk to a building inspector like this, they're going to say, sorry, you're not allowed to use that material, and you'd have to fight pretty hard to get around it.
I mean,
Like
if you're
you put down your polyplastic vapor barrier first and swimming pooled it and then put the stuff inside of it.
You know what would be interesting? Like, if you were really that tuned to the carbon number, then what if you just did EPS for the 4 foot around the perimeter, and then you brought the stone up in the middle of the house to the top of the EPS, did your vapor barrier, and
Interesting.
then did the 2 layers?
Yeah, a skirt of the
You
EPS,
didn't just do it
essentially.
right. So that way there you're minimizing the amount of insulation, but you're not putting in an insulation that would challenge the system. You're still using it, but now you're even minimizing the use of the rigid insulation, which you're claiming is detrimental.
I did have a project in California where mistakenly paper-faced polyiso was put down. It was an elevated slab, but they had a pin plumbing leak from a nail going in that went undetected for over a month. They ended up having to rip out the whole topping slab and all the water-soaked, degraded polyiso underneath of that. That was a
Better hope
real...
your builder's risk policy's been paid.
Yeah, that was, but so, it can get wet from the outside, but how do you protect buildings from plumbing leaks in that situation?
I mean, I appreciate the question. I appreciate the the desire to think beyond. It's there's also the question of when is good enough, right? In that
that house, the first house that you and I did together with the Slab-Less Slabs, net zero plus, they drive their car off of it 50 miles
so
a day.
like there's other ways that like you could argue you're going to balance the use of EPS insulation. I mean, I did another series. It's like the minute we start building, we're in a deficit to the environment.
We've made the impact.
So the question
decided to
isn't
make the
how
impact.
good can you build a building. The question is always to me, how less of an impact can I create? Because you're never going to build a building that has zero impact. You can build a 0 plus energy house. You still have an impact.
Yeah.
I'm going to make a quick note here because under resources for this podcast, Building Green has a special report that they write on all types of insulation.
Building
It's
Green
been-
special report.
It's been updated, like I think this is the 3rd or 4th edition. It's one of those documents, like if you're worried about the environmental profile of insulation and in real applications, it's a wonderful resource. So I'll make sure that we feature that because it's not for free and it's not inexpensive, but it is incredibly comprehensive and fair treatment of all the different insulations.
The conversation about wood fiber or hempcrete in that instance where I say like, well, we can't get it in my market. I've had people try to challenge me on that and be like, well, you should be pushing to be able to have that in your market. I understand from a moral standpoint that you believe that we should be pushing to have the hempcrete people open in our market and supply to our market. And I completely understand the argument of like, if you don't try to do better, nobody's going to do better. At the same time, somebody has to pay for it. Somebody has to put it together. Somebody has to be able to afford it. And when it comes to newer products that are more expensive, there is a line in the sand that our clients, even that are already paying a premium for our product, they draw the line in the sand like, okay, but are we really going to spend 3x on our insulation just so that it can come from trees instead of recycled cellulose?
Yeah. And I mean, I would argue I probably have some of the most willing clients in the nation to do things. And even they say, yeah, I probably don't want to do that. Or I don't want to be the first one to do that.
And it's not that the product might not be a fantastic product either.
No, it's just first one, I always say first one through the wall gets bloody. And it's a challenge, right? If you're trying to be the first one through the wall all the time, sooner or later you're going to get caught. But the other thing too, when you mention, people say, oh, you should bring it to your market. It's like, listen, beyond the idea that I'm trying to do good things here is I run a business and I only have 24 hours in a day.
Yeah.
And so I, like the building, I am kind of working out of a deficit of material decisions, and I'm trying to make the very best ones, but I can't dedicate 16 hours a day for the next week to try and get hemp into my market and into this project when I can just do this in an hour and get it done. And it's not that big of a difference to me.
The other good thing about the tools that Building Green provides for information is there are tools you can use to find out what the pressure points are in the life cycle of the building for different materials with different environmental impacts. Not everybody wants to take the time to run that type of modeling. The good thing about the Building Green Special Report on Insulation is that kind of perspective is woven into their recommendations. And they do have in the back recommendations built the entire sort of profile of the product's performance for different applications in the building. So they make, I think, great recommendations to consider so that you're putting sort of your effort where it's going to provide the most benefit to the environmental profile of the building. But this session, this podcast was also about some pretty cool new projects that you guys are doing with innovative foundation systems.
Before we go there, I have a legitimate question, and I realize this may be different 50 years from now. Have either one of you ever seen a building be recycled?
Building be recycled.
Like when we talk, people talk constantly about like, well, we need to use materials. We shouldn't use spray foam because it can't be recycled at the end of its use. We are very eco-minded, our company.
I guess it
I've
depends
seen
on
things
like when
be
you say
because they're cool.
when you say be recycled, like it's like to what level? Because I could answer yes, but I could also answer yes, but it's not maybe to the level you think. Like I've seen buildings get taken apart where they crush up all the concrete. Concrete goes into a pile. They actually like crush it to the point where they can extract all of the rebar. That gets over in this pile. And, you know, you go by a site in Boston and there's like a pile of rebar, a pile of steel, a pile of concrete, and then, you know, a pile of miscellaneous metals and stuff like that. So they go through and sort the whole thing out. And those are all going to some place to get recycled, I'm assuming, because it's the only reason you would separate it.
So just a quick plug. You know, all my graduate work was done on construction waste management, and we're not doing a podcast on that topic because we think we've covered it before. Listeners, if you would like to see a podcast on construction waste management, we're willing to do one. We're just not sure if we've adequately covered it in the past. But to me, the way this might tie into architecture, Steve, is there's a whole movement on design for disassembly. How do you build into design ways of making it easier to take a building apart and reuse materials or salvage for reuse? And I think one of the toughest things is our control layers are very dependent on sealants and tapes that make it hard to take buildings apart.
Yeah, we've probably made it a lot harder to take buildings apart now.
So that's tough.
I will tell you, when I was working with Artistic Homes, they actually had the Vermeer grinder.
Yes.
And so we would take like all the drywall and it would go through there and get crushed up and ground up. And they would literally have because, I mean, we're doing a project where we had 300 building sites. So they would take where we were going to do like the last 2 sites. They would bring all the construction waste, and they would have a pile of wood crumbles, a pile of gypsum crumbles. So they would recycle all of the materials.
And that was because the Building America program supported me to go down there and work out that system with them. There's a low-speed grinder. It's very difficult to grind materials as disparate or different as concrete, gypsum wallboard, and wood. You know, there's a different grinder for each, but the low-speed worm drive turned out to be the one that could adequately handle all those materials. And that was part of a work of a guy, I can't remember his name, a really cool, probably never graduated from high school, mechanic who knew the right type of grinder to use for that project. And the Vermeer was one of them.
I will say I was part of a panel at a very large conference a few years ago, and somebody asked, what do I think about the future of buildings? And I said, actually, I think the future in buildings is the unbuilding of buildings. Like thinking about how we should take that building apart and what happens to all the components. Because I think while we want to think about how we build buildings, I think there's going to be a lot of pressure on when we tear down buildings.
Yeah.
And I think it's become a lot more prevalent. I know for a fact that what I do now versus what I did when I started as an architect in the industry, we did a lot more remodeling work. Now I have people that'll buy $1 million house to tear it down. Right. And then put a new house on the lot because they don't care. The land is more important than that house. And so how do we get rid of that? And
Jake, your interesting CLT, cross-laminated timber, is interesting because if you build buildings out of large, super durable bearing members, post and beam or CLT, that is in itself a design for disassembly because those suckers can be regraded. Bob Falk did a tremendous amount of work at the Forest Products Lab on developing a grading system for salvaged timbers because one of the things that held it up was like, we can't reuse this with that stamp. It's been inside a building. It's been nailed. It's been all these things done. Bob Falk was a structural engineer who helped to work out a grading process for salvaged timbers.
But I wonder if things couldn't migrate just into a different arena, right? So like you brought up wood fiber insulation. It would be a really good question for the wood fiber insulation. Like, do they need to only use virgin material? Like if we were demolishing all these houses in the Boston area, could we separate out the wood, ship it up to Maine, and could they take it, grind it, mix it with virgin material, and produce wood fiber insulation? So that wood just takes on a different life.
Or an OSB manufacturer.
Or an OSB manufacturer, instead of cutting up trees, they're grinding up old fir 2x4s.
So this is exactly what the work that I did for my thesis was.
Well, you didn't
so,
do it very good because we're not doing it right now. So you should have worked harder. Sorry.
Or the previously coal-fired plant that powers the University of Missouri, they burn wood chips now.
Yeah. I mean, a lot of people, we've been to the Huber factory, you know, they take their wood waste that goes up on a belt and it services their mills. And the same at Roseburg. All their cutoffs, their bark, it all gets separated and it basically goes on a separate belt and it goes up and it becomes part of their kilns or heating systems for their mills.
I started some discussions.
Or they just tell us that and they burn it.
Well,
I started some discussions with Huber about, you know, looking at life cycle of products and so on. And, you know, when you combine functions, when you add a polymer coating to the outside of the OSB, what have you done to its ability to be reused or recycled? So when you combine functions, you oftentimes create systems that are harder to tease out the components. So it's very, very challenging to combine high performance for control layers with design for disassembly or reuse recycling. So it sounds like maybe we should do a topic on this, but let's have the readers tell us whether we should do it or not. However,
they're listeners.
I said readers?
Yes.
You did.
That's because I was looking at my glasses.
I thought it was because you're old.
Well,
Dementia.
same thing.
Dementia, Pete. We haven't used that all yesterday because out of respect.
You think that's funny. It's edgily cruel. But I just have broad shoulders.
Is it cruel because like there's a possibility?
It's too close. Too close to home.
We'll have to
Last
talk.
time
We'll have
we were
to talk
together-
about that a little bit later.
Last time we were together, I said, Pete, you will know that you are actually old when I quit making fun of you for being old. And then I went like 5 hours without making an old joke just to see if he would
So when
notice.
that happens, we can do a significant moments for Pete.
Yeah.
Yeah, it was the time that I forgot why I was here.
There
How are
we
you
go.
doing?
But I haven't forgotten why we're here because you guys are supposed to talk about some innovative foundation systems that you're either about to work with or are working with.
Do we call them innovative? They've
I would say
70s.
alternative.
Alternative.
So
Permanent wood foundation.
yeah, we're
Partnered with
project.
Slab-Less Slab.
Partner with Slab-Less Slab.
Wow.
Steve
You're
and I
knocking
are-
all kinds of
we're in
concrete out.
We're in the design process right now where it appears that potentially the only concrete in the building will be a stoop outside the door.
No kidding.
And it may even be like concrete pavers.
Yeah, well, you get some recycled granite or something, and we'll put it out there. Some big rocks.
It's not a very big building. It's a backyard. She calls it a
It's a she shed.
Yeah, it's a she shed.
It's all about the pronouns.
Sewing studio on one elevation for her, bicycle repair / music listening space.
Irritant
for him.
space for him.
Yeah.
What's the motivation for the permanent wood foundation? Just
We have limited site access. Like, yeah, we're going to get a high lift back there to dig. But at the same time, that may be the only truck that goes to the backyard, period.
so you can carry in the foundation.
Yeah. And depending on when it falls, I think that it's going to be at a time where we probably are a little cold to be trying to pour concrete, which we kind of figured out when we started the process with these people. Like in our schedule, it's going to fall in January probably, or maybe even February. And we're trying to, Steve and I have been referring to it as the Discovery Project.
Yeah.
We're trying to understand alternative methods that we haven't used before, or that we haven't used very often, and whether or not it makes sense to use them on a broader scale.
Cool.
So it really is us trying to learn with very trusting clients that really don't give a hoot what the foundation's built out of.
And
as long as we're
looking
gonna
at
stand on it.
materials that are used in this way, and it's like, hey, maybe we can use that instead of under a slab. This goes up the wall, or does this, or does that. So
And when we talk about building recyclability, it's all wood. There's no concrete to bust up. It's gravel that could just be buried where it is. Like it could just stay if it wanted to. It's an interesting concept. I grew up in one. I lived in one from birth to maybe 7 or 8 years old.
You mean a house with a permanent
A
wood
house
foundation?
with a wood foundation. It was a walkout like this. It's when I say, I said recently on a podcast with you guys that part of the reason that I built a house that was not on a basement but on a slab is that I've never lived in a basement that was dry.
Yeah.
That one was actually dry. The wood foundation
Oh, is that
was actually
right?
dry. Yeah, my dad was panicked about water, so he actually took it serious the way we do. and backfilled with 2 feet of gravel, and it had tar and 6 mil poly on the or 10 mil poly on the outside, and very specific grading and all the things that we asked to do when it's concrete. It had that.
So when can you report back on this project? Do you think in a year?
Yeah.
The next time we podcast, bro.
I think we probably can talk about it the next time not the next episode, but that we record these in bulk.
Yeah.
So I would guess that
sometime in the spring.
Yeah.
Cool.
We have real movement by then. Steve's finishing plans for it next week. I have a meeting with the clients next week. I'm excited.
And we have another one that is steel piers and a slabless foundation.
Yeah. So it's kind of an H-shaped house, very similar to mine in that sense. It's on a sloping site. Garage leads to bedroom wing straight behind it. There's a connector that's elevated, and then further down the hill, but connected at the same elevation, we have a floating assembly, kind of like the Hilltop Aero project, but it's steel piers.
And why steel piers as opposed to?
So we talked about doing it in
or-
concrete. We made a decision to try to be a little bit more cost effective, to use less concrete, and to make an aesthetic choice to drive the house in a slightly more modern position.
And they wanted a single level house. They didn't want to pay for a basement, and the grade is such that if you started on the high side, by the time you get down to the low side, you're probably pouring either a 12 or 16 foot foundation wall, or you're pouring an 8-footer and building a whole second wood framed floor for the basement. So it'd be a walkout plus on the low side.
So you're not talking about helical piers?
No,
we're talking about a concrete footing with
Okay.
like steel columns.
Got it.
That go up, stilts.
Yeah.
Steel stilts.
artistic stilts.
Artistic stilts.
Yeah.
So, and it's a contemporary looking house, so there's a
works.
style
Yeah.
that goes with this. Plus, it's like the site, you're always looking up at the house. So having it on stilts, you're going to have this small form that's over air. So you break down the scale. There's a bunch of aesthetic properties that go along with it.
Interesting that we'll be talking soon about a house that's got a lot of exposed steel on a relatively steep site.
Yeah.
Yeah, so we'll come back to that maybe even soon.
Yeah.
And Steve, you have a project that's
Well, we just finished, we're in the process of finishing the house, but the foundation has been in, and it was it's the second time I did ICFs, but the first time I did it, I wasn't nearly as engaged as I was in this one, where all the details and I actually learned an awful lot, because the guys, I'll give a shout out to Blue Green Building Concepts, who were the ICF contractors in the Boston area, and was it Dan? I think it was Dan and his dad Arthur. They were father-son team, and they were just really good. He was in a bunch of my videos with me for the build show, but I learned a lot. Like, he had all these little tidbits and tricks and ways to do things, and so it enlightened me as to how to do ICF successfully, the tools that they had specifically for the ICF wall foundations and such.
it's interesting how when you talk about different systems, it's also people who have enough experience to know the tips and tricks for that particular system.
Yeah.
Which
Can
that
sell
people
you
can
on a
learn about.
system.
Yeah.
Yeah.
As soon as you see it done well by professionals, you're like, oh yeah, that can be done and not be a pain in the rear.
And so those tips and tricks with ICFs are part of the build series on that particular project?
Yeah, I mean, for that one there, I've went over a bunch of them in the videos and talked about them and why they do things. And
Kind of cool to be able to link a podcast to other resources.
yeah, certainly. And but it definitely turned my head onto ICF's not so bad. They're good. The problem we have in the Northeast, just so people understand, they say, oh, you should have just done ICF. No matter what I put up, no matter what video, we're doing Build Show Build Boston, and you put up the foundation video, people are, oh, you should have done ICF. Okay, we priced it.
To be fair, you should have.
Yeah, and we did. It's not even in the same zip code, the pricing. unfortunately. You know, so it's a real challenge. And I mean, I'm doing some ICFs in a different location. We're actually going to do ICFs. We're going to do light deck. We have like 3 or 4 ICF houses that we're working on.
What is light deck?
Light deck is it's the floor assembly version of ICF.
Okay.
So it's like a molded EPS double T form.
Okay.
So the ICF comes up, there's a haunch, you put this on it, and then you pour a 3-inch topper slab, but it has the 2 ribs that you can reinforce too. So you're basically building a parking garage that you're using the EPS as
Gotcha.
the formwork.
Interesting.
It's interesting that for a lot of technologies that are new or innovative or alternative, you often will say, yeah, if you put together all the performance advantages, it oftentimes sort of pays for itself with the cost of the product, and you're just not there with ICF.
It just, in our market, it isn't. It was like, you know, for the Build Show Build Boston, we priced it out. It was well over 2x.
Yeah.
For the foundation system. And when I can put the foundation wall in, put the slab in, frame a wall, insulate it, and wire it in the basement, for the same price I can get ICF installed without a slab. It's hard for me to sit there and tell the homeowner, hey, we should do ICF.
So I imagine
Right.
the Superior walls, which you've recently used, are not inexpensive per square foot or linear
No,
foot.
but that was
But
kind
math
of
out a
they
lot easier.
math out a lot easier because in that system, ICF is insulated too. But
Yeah.
the Superior wall system that we just did, it's already at R21. It already has holes
Yep.
drilled for wires, 4 holes per vertical segment.
Yeah.
And the price to go from 9 to 10 feet on that was like $4,000 or something.
I'm just trying to point out that
It was like $10 a linear foot. Imagine that.
Your resistance
to add another
is,
foot.
Yeah, your resistance is not blanket; it's tuned. to
Exactly. It's like
educated.
I'll work with anybody, but it's like we just don't have a lot of ICF people up by us, and it's not a competitive market for them where it's driving the price.
Yeah. So in terms of resources, we got a whole bunch of good ones for people to follow up on this, and
Yeah. I
those
mean,
will
we
be right in the
even
podcast.
tried to do the ICF. I wanted to do the pool out of it because those ICF guys did it, but we priced it. It's like it's not in the same zip code. You know, it's
Cool.
It's hard. It's hard, and that's probably the problem to kind of circle back with the whole hemp and wood fiber. And it's like to bring it to our market. It's like we want to try it, but you bring it there if it's 2 or 3 times the price of EPS. Now, granted, that's not a big number, but when you look at the Johnsons, I mean, what did we have for EPS number in that? It's probably like $4 or $5 grand worth of EPS.
Yeah, I think we were probably close to that. It might have even been a little cheaper than that because we did that pre-COVID.
Right.
You know.
But let's just say it was $4 grand. If we get some other insulation in, now it's harder to get, right?
Yeah.
We might potentially have to wait on it because it isn't a real streamlined distribution.
Mm-hmm.
So those things never go well.
And we never order enough because it's expensive and we don't want to burden
And then
the
you're
clients
gonna
with
run
20%
out.
waste.
And oh, by the way, instead of $4 grand, it's going to be $7,200. It's like I'm paying extra for a very large inconvenience, and that's one of the.
But
And
the
I'm not saying
client's
that's
never going to have a visual or
and it doesn't make a
recognition of
difference
what it is,
in
I should say.
performance. It just is a difference in the environmental column, right? And so it's hard. I always want to do the right thing, but it's like sometimes the right things are just beyond the capacity of the project.
Yep. That's a good place to leave it.
yeah.
Give
Who's
a
taking us
story
out?
for us?
Well, I don't have a story. I just got a quick one. So, what do you do when a bunch of clowns come and attack you?
What?
You go for the jugular.
It's sad, but I love these. I have to admit, I love play on words.
The problem with the play on words is like you think, like and you anticipate, like this is just going to be so stupid, but it's an exciting stupid.
Yeah. And I'm not
That's a
quick-witted
good
enough
title for the episode. Exciting Stupid.
I'll make a note of that.
Steve Exciting Stupid Bezek.
There you go. Got to be somebody, right?
I'm Jake Bruton. Thanks for watching today on the UnBuild It podcast. Don't forget to leave us a 5-star review on iTunes. Don't forget to subscribe on YouTube. And now you can find our content on buildshownetwork.com as well. We're excited to be part of the Build Show with Pete with us now. Until next time, have a good day.
So long.
So long.